Good morning, good afternoon, good evening, everybody. Thanks for joining today's webinar. We've got a great webinar planned, including a really good end-to-end demo, talking about how to build end-to-end blockchain solutions with Kaleido on AWS. We will be recording this webinar, so if you have objections to that, you can log off now. We will also be providing both the recording and the slides to everybody who registered for this webinar after the conclusion of it. So with that, let me just do a quick introduction of our two speakers today. We have with us Peter Broadhurst, who's the co-founder and head of engineering at Kaleido. And we also have with us Carl Youngblood, who's with Partner Solutions, who's a Partner Solutions architect with AWS. So with that, we'll dive right in there. If you have questions during the webcast, please put them in the chat, and we'll try to get to as many of those as we can. And with that, I will hand it off to Carl.
Great. Well, I'm really happy to be here with you guys today, and with Peter joining me to talk about some exciting solutions for blockchain applications provided by Kaleido and AWS. One of the I've been, just a little bit about myself, I've been working in software engineering for over 20 years now, and I'm specializing in blockchain technology and working with several of our blockchain partners, including Kaleido at AWS. And Peter is the co-founder and head of engineering at Kaleido, and great to have him joining me today. So one of the first things we wanted to jump into as we talk about blockchain technology is the nature of blockchain applications. So if we could move on to the next slide. One of the things that we often say as we're building blockchain applications is that although it's an absolutely critical part of the stack, the blockchain piece of any decentralized application is only actually roughly 5, maybe max 10% of the whole solution. And a typical web application or internet-based application will have several components that generally involves cloud technologies of various kinds and several layers of the stack. And many of you have already been developing applications with these other layers. And a blockchain provides you with a way of having an agreed upon source of truth that isn't confined to any single organization. And so it enables really exciting new possibilities, but it's still only one small piece of a larger pie. And so as we're talking about how to build decentralized applications, we always like to start out and emphasize this important fact because there's still a lot of other work that needs to be done. And that's one of the reasons why Kaleido has built some of the tools that it's built. So I think I'm going to, at this point, turn it over to Peter to talk a little bit more about the specific demo that we're going to be showing today.
Yeah, thanks, Carl. Apologies to everyone for my slightly gruff voice on the call today. I've been on the road for a couple of weeks and it seems to have taken effect on my voice, so apologies for that. I hope everyone can hear me okay. So as Carl said, this chart really represents Kaleido's view of where we've seen from real production applications, and we're really lucky in Kaleido to have lived that journey through the pilots and through the POCs and the pilots and into production with real blockchain-based business networks. And the feedback we've had has never given us a level more than 10% of the overall solution being the chain itself. And what's so interesting is that the stack that's required to solve these enterprise requirements, building next generation applications, reinventing business processes on a modern digital platform with blockchain at its core, actually looks like the traditional enterprise stack that myself, I've been working with pretty much in every layer of the middleware stack in the traditional space throughout my career. And it's so interesting that when we look at the pattern of the development of these solutions, that the same layers tend to exist. The core layer at the base, for example, where the data is so critical. And one of the most interesting things we've observed is that while the blockchain is the beating heart, the actual amount of data that can be stored and shared between all participants on the network is actually a very small amount of the actual data that exists. Usually most data in an enterprise context is sensitive. It's maybe regulated, it's large. Trying to share that all on an immutable ledger that can never be changed and visible to all participants in the network is not actually really very practical. I wonder, Carl, if that's something that you've also seen.
Absolutely. So there's some kinds of data that, as you probably would imagine, the various members of any consortium that's involved in blockchain are not going to be that comfortable placing on a blockchain. For one thing, you pointed out how it's immutable, right? And as we know, there's some data that we're required to be able to delete, such as personally identifiable information, or PII, and other things that a particular enterprise may feel a little sensitive about, and may want to confine their sharing of that data to a smaller number of participants, or even not share it at all. So that, in addition to the fact that there are some kinds of data that's just impractical to put on a blockchain, because it's blockchain, in the sense of the purpose for which it was built, was not designed to carry large binary blobs, for example. So what we often see is some kind of hybrid where different data sources are used for their particular purpose, and also where certain types of data that are more sensitive are shared in other ways, or stored in other locations. So I absolutely agree with that observation.
And that theme really carries on up the stack in our experience. When you look at the transactional layer, which of course is so critical in the blockchain layer, you look at the way we represent this in Kaleido, the very first thing we think about is actually privacy. And we spell privacy at least 4 different ways inside of Kaleido, and we'll be seeing some of those as we look at a use case and a demo. But at the transaction layer, it's not just about the pieces that you're trying to hide. It's also about trying to get those new ways that transactions need to interact from your systems into the blockchain, and also making your existing systems react to events that are happening from all the participants in the blockchain. And it's actually quite a sticky, practical, technical problem. Blockchains don't behave the same way as a traditional database. You need to drip feed the transactions on.
I think another thing that we often see, and perhaps you've also observed this, Peter, is that even though the various organizations that participate in a blockchain are eager to leverage the shared data that they are sharing in order to achieve more efficiencies in the ways they work with each other, they also experience a little bit of trepidation around the idea of sharing their data so freely, and making sure that their data is, the data flows are working in the ways that they intended them to, right? There's a little sensitivity there.
Oh yeah, 100%. That's, it's interesting. So when you start a conversation with a business network, and of course this is not about the technology for us, this is about the solutions. Almost the very first conversation you're having, when you talk about sharing data, is the fact that these businesses are almost certainly going to be in competition with each other. They're thinking about how do they build a business ecosystem in a new way. It's fundamentally different to all of the previous systems that they've built in past generations of B2B networks. And what makes them different is sharing that data. But also what makes it different is collaborating with your competition in a different way. And actually thinking about what data can be shared, what data can't be shared, how your transactions are going to be visible to others in the network, what information people can glean from whatever visibility you do provide is really interesting. We're actually going to come back to that, aren't we, later in the session, Carl, and talk about some really interesting and innovative solutions for providing privacy in these networks.
Yeah, definitely. And just in case you guys didn't catch it, there was a bit of a coin of phrase here with the word co-opetition, right? It's something that I think I might have heard before, but Peter was one of the ones who first used it around me. And it's just, driving home this concept that the same businesses that are collaborating in a blockchain setting are often also offering services that overlap in some ways, or this often happens anyway. And so, blockchain enables entire industries to achieve greater efficiency. And within these industries, there's always a little bit of overlap and a little bit of, concern around each company's particular services and products that they offer. So these are some exciting, but challenging, or interesting new challenges that we run into.
Yeah, I completely agree, Carl. And it's interesting as we move up the layer when we talk about the middleware stack, and for us, this is probably one of the most critical pieces. You actually find that so much of the communication around an end-to-end business transaction just can't go near the chain at all. We see it's really common to see actual off-chain messaging, application to application, real-time collaboration on the transactions to be many to one with the actual transactions that can go onto the chain. And further to that, and we'll see this later, but a lot of that messaging is around large documents that cannot go on the chain for very significant reasons. But all of the transactions on the chain actually need to refer to those documents in meaningful ways. So actually this layer that can integrate between the businesses, but then maybe most importantly, integrate from all of this new business network technology and integrate that with the existing systems of record and the existing application infrastructure running in many cases in really modern cloud native ways on platforms like AWS. That's actually really critical to be able to get the connectivity in and out of that data. And that's how we think about this middleware tier and the connections it needs to make back into your core systems.
Absolutely. Yeah. One of the important points you make is that, we've got a lot of infrastructure already. We've got a lot of cloud APIs, web services that are already available. Many of the companies that are building these new decentralized applications may already have systems they rely on. And we're not necessarily asking them or proposing as they build these new dApps that they would abandon all of this existing infrastructure. In fact, many of them, can't. They rely on several of these services to get things working. And maybe some of these services, they will even be linking to blockchain in some ways. And so we're not necessarily, as you go about, building your first decentralized application, you shouldn't need to reinvent the wheel essentially and do everything from scratch, but should be able to leverage the existing services and just do new enable new things with blockchain technology.
And it's interesting you say I'm using existing now as well, Carl. That it's not just the technology that's existing; it's also your skill set. You've got in your enterprise IT organization, you've got all of these fantastic skills around building apps using modern web-based technologies, about integration using the core infrastructure. Maybe you've got an AI platform, an ESB, or other integration technology. You've got specialists who understand how to integrate all of those existing systems into modern web-based or web services-based applications. Those skills should be able to connect to blockchain infrastructure just as easily as they can everything else. That's something we've really tried to focus on in the Kaleido platform.
Yeah, that's something I'm really excited about what you guys are doing. I mean, there is this kind of fear that I think a lot of even experienced developers have when they first learn about blockchain and realize that some of those base layers are radically different from what they thought they were. And what you've done to help bridge that learning curve is really impressive. So I'm excited to be showing some of these solutions today with you.
And there's maybe a really good segue there, Carl, to actually start showing something. As we talk about the application layer, I think a really important thing to say about how Kaleido views kind of the enablement that we're able to provide is that we're not actually about building a vertical solution for an industry. We're not actually about providing an infrastructure for building applications. They're fantastic platforms. Absolutely, AWS is one of those real leaders in trying to make it so easy to build applications. But what we'll see is we actually look at an example and we move from kind of talking about the landscape to showing is that there are some interesting new concepts that make building these applications different. Things like core constructs that you would imagine in a centralized database application, either rows and columns in a SQL database or a NoSQL document-based system, or suddenly you're talking about these digital assets. What are they? What are tokens? Where does cryptography fit in? What are these new kinds of approaches? And we'll get into that in a couple of ways as we go through some of the examples. So just moving on here to sort of segue into a real use case. We were considering in Kaleido, how can we actually demonstrate a real example of the kind of end-to-end solution that gets built with blockchain at its core. Now in Kaleido, we're very much cross-industry and we see the use cases all across the board, but there's a really interesting set of use cases which aren't the traditional token-based ones. We'll look at that a little bit later, around data, around this real construct of having private data that's valuable to you, but also can be cleansed and enhanced by the participation in an ecosystem. And we considered actually, well, let's look at one that we've got some experience of. Let's look at one that's a real pain point. And we looked at the healthcare industry and provider data management. So this isn't your medical records of individuals. This is just about when you're talking to your health insurance company and they're giving you information about the doctors in their network, how up to date is that information? It's really expensive and complicated to keep up to date. And it's actually a real pain point. I don't know, Carl, if you've ever had an experience where you've found actually, this data can be really, really inefficient and incorrect as it's maintained between the different health insurers, et cetera, in a particular industry.
Definitely. I mean, whenever you have human entered data, there's always this risk that there's a lot of messiness, lack of uniformity in the way the data has been entered. And you also have this issue where maybe some sources of data are very reliable and others are very unreliable, and that different organizations who are participating may be more of freeloading, let's say, off of the largesse of others who are working more diligently to maintain that data, right? So what's really interesting about this demonstration that we're looking at today is that we use a token-based economy to allow this, to help incentivize the curation of this data. And what's fascinating about how this is achieved is that when you have a cryptographic token, as we'll be using in this demo, essentially you've got something that's provably scarce. So you can set a certain circulation of a certain amount of tokens that are available in the entire ecosystem, and provide some means by which participants in this ecosystem can both acquire tokens and also can spend those tokens. And so the idea being that if they want to if they want to gain access to certain data that's been made available, they would have to spend certain tokens. And if they provide certain data to the ecosystem, then they may also earn tokens for providing that data. And the hope with this token economy is that this will incentivize both parties to be participating, to be providing data. And if you sort of run out of your, you have no tokens to spend, then maybe you better start providing more data and adding more value to the system, essentially. So a token economy can be used to maintain the health of a sort of shared commons area, and avoid that traditional tragedy of the commons that we've often heard of, right?
Yeah, absolutely, Colin. And now we're showing you this from a healthcare background, but actually this is really a cross-industry pain point around data marketplaces. So this is just kind of one real example of where blockchain can make a difference. Now, I'm hoping that there's lots of technical people on the call, and we are going to drop down and kind of look at what we've built and go through a demo. And there's a second demo after this, so I'm going to push ahead a little bit more. And talk about kind of the infrastructure behind what we're going to show you. Now, what we're going to demonstrate is a scenario where there's actually three, only two shown on this chart, separate sets of infrastructure which are running in completely separate AWS cloud accounts, where we have a decentralized application. This is a very straightforward app. We're going to look at a little bit of the code. We set aside one developer for 1 week to build this, so it really is just a straightforward and simple demonstration of the end-to-end, what can be achieved by assembling pre-built services into a sort of blockchain-backed solution. And what we're going to see is that with a blockchain at the core, with identity and a permissioned private chain that is shared between a set of participants, we have some private documents which are going to be maintained individually by individual participants, combined with off-chain caching and an index that's maintained individually by each participant in the business network in a document database with a MongoDB interface. We also have, and this is really quite critical, and we'll see it as we go through, we have each one of these application stacks, these unique per organization stacks, listening continually for events using the event streaming technology built into the Kaleido platform that does at least once delivery, triggering logic that's really straightforward, able to be just run like in a serverless function or any way you wanted to host that. So AWS Lambda in this particular example, detecting what's happening on the network, reacting to it, caching that data, triggering business logic. And we'll see all of this play out as we run through, and we'll move to some conversation showing the demonstration and maybe come back to some of these details. Carl, was there anything you wanted to add on the architecture picture?
Well, so one important thing, I guess, just to call your attention to, is that we're showing here that we have several participants, right? And of course there could be additional organizations that aren't being shown here. But yeah, I want to emphasize that each organization is keeping a separate copy and has some data stores that are exclusive to them, right? And the various integration points are really really interesting here. And we got a few questions on the chat side as well. And I don't know, Peter, if you were thinking we would respond to some of those as we go, or if you'd like to hold those off until the end. What are you thinking?
So there's one question I can see here that's open. How are we sure that middleware is secure and giving provably true data? Well, I hope we'll find that that's answered during the demonstration. And let's maybe come back to that, because it's a critically important piece. And it's actually where some of these technologies like cryptography, like end-to-end encryption, like hash pinning of the content of documents, referring to them by payload, rather than referring to them by their location, is actually a critical part of building this kind of solution. And you have to think about it actually as you're designing the application, as well as you're integrating it into a shared connectivity tier, such as the Kaleido platform, that's providing that orchestration between the organizations. So I think maybe, Carl, let's have a look at the demonstration, and let's come back to some of those questions afterwards. Does that sound like a good idea?
Yeah. I think that's a great idea. I think some of these questions will be answered as we go.
So what I'm going to just show you here is that we've got three separate instances of a simple application. We've got Organization 1 instance. You'll see they're all in different AWS instances here. Organization 2's instance and Organization 3's instance. Now, all of these are partnered to a set of individually owned infrastructure inside of Kaleido. Now, I'm actually managing all of these bits of infrastructure under a single cloud account inside of the Kaleido infrastructure. But in a decentralized model, what you would actually do is you would have separate logins into Kaleido, separate cloud accounts. But the tenancy model of Kaleido is built from the ground up for these decentralized scenarios where you have individual infrastructure owned under separate accounts, but cross-connected on a secure backbone with a tenancy model that creates a secure layer 2 virtualized network around that environment, so that there is cross-connectivity, but there's also extremely strong shielding around that environment inside of the managed platform, as well as connectivity out to your own data and your own keys, which can, for example, be secured using the AWS KMS infrastructure to provide a cloud HSM that additionally provides security over your key materials or backup to your own AWS S3 environment for each one of those nodes.
Now, one other thing, though, that's kind of interesting that you've shown here is that it is still possible for a single login or one organization to manage another organization's blockchain infrastructure, which may in some cases be interesting or useful to certain organizations that want to outsource or share the administrative responsibilities there. So I think that's also very convenient that you can kind of slice and dice the responsibilities however you feel works best.
That is an absolutely great point. And actually one of the most important pieces of building a permissioned private blockchain network, which is at the moment where the majority of the value capture and traction is happening in the enterprise blockchain space. And evolving models, topic for another day, as we see the evolution of public and private with the next generation of public networks kind of on the cusp here. But actually in this environment, what I've got is a whole bunch of organizations that I'm managing under a single cloud account now. Great for a POC environment before you're ready to do the full decentralization of ownership. But even there, what we've done is we've pinned each one of these organizations to an identity backed by the kind of traditional PKI certificate-based identity that you know and understand from your existing PKI trust chains that you've been building for example, your web servers that are running in your AWS infrastructure. You went through a ceremony for each one of those to prove its identity and make it trustable. We actually see the same thing in a blockchain network, that you need to prove your identity as an organization and link that to the identity of your accounts and other profile entities. And we've actually worked in Kaleido with the Enterprise Ethereum Alliance to make this part of the next standard. And we're working towards getting that. It's been discussed and approved, and we're just working towards finalizing that in the standard going forwards. But actually, this is something that's been part of the platform for some time, a standardized mechanism to pin that on-chain identity on the blockchain to a real trusted root using X509 certificates.
Yeah, and I'd just like to add that, if for some reason your organization needs a solution for certificate management, there is, of course, AWS Certificate Manager that they can use. And Kaleido's done some great integrations here where, of course, as you said, if you already have your existing PKI infrastructure defined and already have some root certificates generated, then you can definitely use those. But the other great thing is that, if you don't, it's really easy to use Kaleido to generate your own as well.
So let's, with no further ado, let's just go and have a look at actually the application itself, looking at these three separate instances of the application and looking how businesses on a business network could collaborate together with this simple example of a data marketplace. Now, let's look at an example where I'm organization one and I have some private data. In this particular example, I've spent the resource and effort to go and find out data about a particular doctor. I want to keep that data private, but I also want to share the fact that I have that data and maybe others are interested in that data and they'd like to request a copy of it. So let's go and actually find that data. Now, actually, in this case, I am going to share a little bit of data on the chain itself for discoverability purposes. Now, here's the start of a longer conversation that we have time for about what data actually can make it onto the chain and what data can't. In this simple example, I'm going to provide the national practitioner identifier and also the doctor's name that I've gone away and I found all of those details about. And actually all those details that I've got are inside one of these private documents. In this particular case, it's a standard industry format of FHIR. And inside of here, I've got sort of more details of this doctor. I know a little bit about where they work. I've done the due diligence to find out, are they currently practicing? What's all of their background? Is this their current number? What's their clinic hours? And I've got all this data, and what I'm able to do is I'm able to pin this data in my own private store to the chain. I'm just going to really quickly just take a look at what that looks like in this really simple example. So I'm going to take that file and I'm going to submit it. And actually multiple things are happening behind the scenes here. With a few very simple REST API calls to Kaleido, I'm uploading this document to a hash pin store by content, which is private inside of my own AWS storage. And I'm publishing to the blockchain the information that this exists. Events are flowing through the system, and immediately I'm able to go to a different organization's environment, and I'm able to see that information is there, but I'm not able to download it because I only see the information that's been shared on the public chain, distributed automatically through the business network. I don't actually have a copy of this data. The data is only inside the private storage of that first organization at this point. But you can see how many things happen behind the scenes in order to actually make all of that happen, but only with a very few set of simple API calls made onto the chain itself.
Yeah, and as I think you'll be pointing out, there's also ways of verifying that you haven't already got this data, right? We've got some kind of a cryptographic hash of the data that is being uploaded, correct?
Yeah, that's exactly it. So let's have a look behind the scenes, and let's have a look in Organization 1's document store. So in this particular case, this document store is just backed on Kaleido storage. We'll see a more real example where you would actually have that in your own private cloud account using S3 storage in AWS. But what we've got here is we've got an upload of this doctor's details, and Kaleido's automatically generated a hash of the payload of that document. Nothing to do with what we've called it, nothing to do with where we put it inside of the AWS storage. I could have uploaded it directly to some AWS storage, or uploaded it via the Kaleido APIs as we did here with just a very, very simple call just to do a put. This was the sum total of what was required to upload it to Kaleido, whether it's Kaleido back storage or AWS back storage. And Kaleido's done that indexing. And the interesting thing here is that we can see if I grab a copy of that hash on this document store, I can go and I can do a search by that hash, and we'll find a copy of it. But if I go to the document store of, let's say, Organization 3, and Organization 3 has AWS storage in their own account, and I do the same search, we'll find that I don't find a copy of this document because the document doesn't exist inside that private storage. But this hash is the thing that pins that data to the on-chain transactions, so that the transactions that are running through the chain are actually referring to this by its payload, not by its hash. I'm sorry, not by its location. And I'd like just to dig a little bit more into some of the details of actually what happened under the covers as we were performing that. To make these applications really easy to build, you really need to have very simple, straightforward interfaces to be able to submit these transactions, coordinate these activities. We saw how easy it was to submit the transaction to the to submit that data up to to the chain. But we can also take a look and actually see how easy it was to submit the on-chain transaction using Kaleido's infrastructure. If I navigate back out and I actually have a look at the node, the blockchain infrastructure that organization one is using on the chain, and I click connect, you'll see that Kaleido provides two ways to connect to a node. It provides those rich Solidity, Ethereum specialist, or blockchain specialist interfaces for the developer of the on-chain contract. The person who's developing, for example, this marketplace contract written in Solidity that was built by us as part of this decentralized app. And inside of there, they were building using, I don't know, Truffle, for example, as a developer ecosystem. They were building all of these methods, etc., on the core. Almost think of it like a stored procedure around the data that's being stored, or like a class you would have in a object-oriented language. And there's all these methods on here, but actually getting transactions to these methods, getting data off, is actually quite a long and involved process. So in Kaleido, what we do is we provide you this door on the right, which allows anybody with application development skills to reliably submit transactions using secure credentials to the chain. And what we've actually got is we've got an automatically generated REST API that came along with that contract when it was deployed. And we can see, just viewing the built-in exerciser for the Swagger here, we can see the set of interfaces which are available have all been turned into trivially simple to interact with REST APIs, but the application logic, using a couple of lines of code that anybody knows and understands, is able to invoke. And also all of those subscriptions that are posting to that AWS Lambda service to automatically synchronize that data around the environment are all extremely simple to subscribe to using the same REST API, JSON payloads, simple documentation generated from the developer docs, which are in the comments on that Solidity, just what you'd expect from any application development stack. That's really, really necessary. And just the last point as I'm talking here is that this is all backed by a very reliable infrastructure that deals with all of the really nasty and hard things that you're going to have to deal with in the blockchain environment, such as this is about coordination of transactions to get into blocks onto a chain. It's not the same as just my own database and my own infrastructure. These are going to take some time to propagate through. I'm going to need to deal with the fact that this is a lower level technology at its core, with these more sophisticated OLP encoded data structures. They're going to need to be drip feeded onto the chain. Well, that's all plumbing you'd expect to be taken care of for you. And it's really important to us that it is taken care of for you. And we use best of breed technologies like Apache Kafka to do that feeding, do that drip feeding, do that management onto the chain.
Yeah, so just so I'm following you fully, it sounds like what you're doing is sort of inference on the ABIs of these Solidity contracts that are being created, so that you're automatically knowing what types of data, you know, the visible methods on that contract, and what types of data they expect as parameters, what types of data they return, and then you're also managing. It looks like, you know, every blockchain, even a private blockchain, has a certain throughput, a certain amount of transactions it can handle. So what happens if it's a sudden influx of a bunch of data comes into these contracts? It sounds like you're saying that the API and the Kafka processing makes it possible to make sure that you're not losing any transactions in the process of submitting data to those REST APIs, right?
That's exactly it. And the reality is that every single production business network with blockchain at its core is going to end up with an orchestration tier like this, that's carefully orchestrating transactions onto the chain, and also orchestrating those events with at least once delivery to all of the business logic, all of those event-driven applications that exist, and the systems and data syncs that need to happen off the chain. So building all of that from scratch for every project is a very inefficient approach, and we really want to just package that up, make it available, just build it into the platform so that you can focus on the business logic, you can focus on your app, you can focus on the value that you're delivering, not just the plumbing.
Absolutely. This is awesome. I mean, especially, this point about event streaming, getting your transactions in is an important part of the equation, but you also want to make sure you don't miss any of those triggers that happens after the data goes in, right? So yeah, this is a very comprehensive solution. It's great.
And what I'm just going to do is I'm just going to complete the process here, and we do have another item that we're going to move on to, as well as a couple of questions we'd like to take at the end and leave a little bit of time for that. So I'm going to push on, and we're just going to talk a little bit about that document transfer and look at actually how it happens end to end when organization 3 that doesn't have a copy of this data would like to get a copy of that data and where the token economy fits in. So what I'm going to do is I'm going to move across. I was showing organization 3 before, so let's go and have a look there. And I'm going to go and I'm going to see that Dr. Leonard McCoy, there's some information that's been published about organization 1. And I'm going to use some of those tokens in this token economy. Maybe this is about real, actual value. Maybe this is about a health system that's sort of utility token that's keeping the network healthy and encouraging good behavior. And I'm going to click purchase. And what this is going to do is send another transaction to the chain, drive another event on the other side, trigger a trivial piece of logic running in a Lambda function, send an API request to Kaleido to say, hey, I know the identity of this other party. I know they have committed to transfer me tokens, and we could talk about atomic swaps, and they would fit in, and delivery versus payment. But basically, all of that's happened on the chain. It's triggered a simple REST API call. It's sent the document across. It's been broken down. It's been compressed. It's been encrypted end to end. It's been split into chunks. It's been delivered across a reliable transport, and it's all there. The tokens have been deducted on this side. The tokens have been added on this side. And I can just click download, and now we've actually got a copy of that document now available that I can download. And all of this happened behind the scenes a lot quicker than I could talk through it. And what you'll see is that if I now go back to Organization 3's document store, and I click on that search again, and I search by the hash, we actually will now find that same document living somewhere in a received folder inside of that private AWS storage, but I can refer to it by its payload, by its hash. So this is deterministically linked to exactly the data that was published in the data marketplace. There is this intrinsic tie between the data that exists in its entirety in private stores, audited stores, where I know who I'm sending it to, I can prove who I'm sending it to with end-to-end encryption, and also the on-chain transactions which are visible to everybody. So for example, if I go back to organization 2, you can see it's listened to the event, and it can see that organization 3 purchased a copy of this, and maybe that makes it more interesting to them. Maybe they're detecting this in applications, and they're automatically going to run some business logic that's going to automatically purchase this because they've seen enough other people in the environment purchasing it. Or maybe some logic that's tied to how much balance they've got in the ecosystem. So it's a really dynamic network that ends up getting built, submitting transactions, reacting to transactions, managing private data as well as public data, kind of all backed by reliable infrastructure that's able to deliver using very traditional approaches combined with identity pinned to the blockchain to reliably deliver this data end to end and store it inside of very private stores that are individual to the different organizations.
Yeah, your point about how about the data that's being stored on chain and how it could be analyzed in various ways is really, really interesting. As you're developing these applications, the amount of information that we want to share is always negotiated and determined and generally planned as part of the DApp development rollout. And then there may be some additional interesting ways that data can be used that only emerge as you watch the behavior, right? You start to notice different things that are happening, and this may be another way of um, tracking which data is interesting and how that data is flowing around in the network. So it's really exciting to see how incentivization systems and other kinds of constructs that we see in decentralized applications can have ramifications beyond their initial use cases, right? So.
Absolutely, and some of that analysis is incredibly valuable and drives the ecosystem and is exactly what the organizations want. Other times, some of that analysis is exactly what organizations want to protect themselves against with privacy-preserving technologies. Right. And we saw some of those privacy-preserving technologies in action, such as having your data off of the chain, having application-to-application messaging happening off the chain. There are other technologies such as submitting your transactions using identity masking wallets like a hierarchically deterministic wallet that uses a random address each time you submit a transaction, combined with solutions only possible on private chains like not using gas in the system in order to not need funding to be able to actually have submission of transactions on the chain, or even isolating and partitioning your network into lots of different subnetworks, which are sort of either complete blockchains or actually much more commonly nowadays we see sort of private state enclaves, which are just a transaction history for a small section of the transactions happening between multiple participants, but are only visible to those participants on the chain. Still using shared blocks, still using smart contracts.
I guess we're going to get into some more of this, right, with these zero knowledge proofs that you wanted to discuss, right?
Yeah, absolutely. And in the last few minutes, it really is a teaser to kind of a longer discussion on some of this privacy preserving technology. And maybe if you have a look, we can share afterwards. You can have a look look me up on LinkedIn. You can see I was doing a presentation a couple of weeks ago on at the ZK Proof meetup about all of these technologies and where this merging off-chain compute technologies like Hyperledger Avalon, which we're involved in Kaleido, or zero knowledge proofs. This off-chain compute is this new emerging place where you're able to do some really interesting and innovative things. And I'm just going to give you a teaser of a type of example, coming back to maybe a more finance example. Obviously, there's lots of industries we work with in Kaleido. One of those being the finance environment. I'm here at the Singapore FinTech Festival this week, so this one's top of mind for me. Looking at actually maybe when you're transferring an asset, maybe when you're transferring some value, maybe when you're trading something inside of a system, you don't want everybody to be able to see what you're doing. You'd like to do it in a way where you're hiding that information. You're hiding the amount that you're transferring between organizations, but even more than that, you're hiding the participants. You're anonymizing that. And we're going to look just in a couple of minutes before we take questions at kind of an example of performing some transfers in a private way. And this is where you look at the top of the application stack and you look at some of these modern off-chain compute approaches that can be used inside of your application tier to do things in a really new and inventive way.
Excellent. Yeah. So I'm excited to see more of this as well. And one of the things I think is really exciting about what you're doing here is that typically ZKPs are kind of exotic and rare, and they maybe people have a little bit of not everyone fully understands them, let's say, and so it's exciting that you've made some simple building blocks that people can use to take advantage of this new technology. Who may have been a little, they may have been a little afraid of it, right? Because of it's kind of an emerging tech that's still in the process of being developed. In fact, it's a really an exciting area of cryptography right now. You're muted, Peter.
We're going to look at this example end to end, but this is around one use case which is extremely well proven in the zero knowledge space, with lots of different technologies that have actually built this same use case. Zcash in the public space is the most the one that's maybe most well known, and we've actually partnered with Kedit, a specialist in the space that's been involved in the ZK family since its inception, and as a kind of a real specialist partner we have in the space that can provide a lot of detail of how you can extend to new and innovative use cases. But what I'm going to show you is actually built into the platform. We've taken one of the technologies that solve this, actually one of our really communities that we're very friendly with, we've been working with throughout Kaleido's journey, Quorum, packaged up and enhanced the technology called Sigma Bullets, the Zephyr way of performing these sort of shielded transfers, and added some anonymity extensions on top of that. And what we're going to look at just in a minute or so, and we can share some videos where you see this all being set up from scratch, is I've got a separate environment where I have just a couple of nodes here, 2 different participants, and as well as their nodes, in this case, in the stack services that we provide for the application tier, they've got our zero knowledge proof token trading service installed, which comes from our Kaleido Labs team, which is also a demonstration. This is really early adopter technology that's evolving really fast, and there's lots of different approaches that may get involved, and maybe you partner with a specialist in your journey to production. And what we're actually going to see is that you go inside of here and we have a token. This token was deployed using Kaleido's contract management. It's tracking all of the details about this token. We've got wallets associated with this token. We actually have anyone could see this sort of simple token that's been deployed. It's an ERC20 contract, but we've also deployed alongside it a dark version, a shielded version using this anonymous Zephyr approach. If I click into that shielded version, you can see that for this organization, I've got a whole bunch of wallets where there is a public wallet that's visible. And in this, you can see every public wallet can be paired with a shielded wallet. And what I can do is I can take some funds that I've got that are visible in this outside world, and I can bring them kind of in a suitcase into a dark room into the shielded transfer dark room. But this is kind of an interesting thing. I'm walking into the room with a briefcase full of these tokens. It's visible that I've done that.
Some interesting imagery there of walking into a dark room with a briefcase full of tokens. But yeah, this is exciting.
So what I'm going to do, I actually have a heck of a lot of these tokens in the public space under this organization's public wallet. And what I'm going to do is I'm going to take a few more of these tokens into the private darkroom. What we're going to see is if I add a few of these, I click a button, Kaleido's generating an off-chain zero-knowledge proof, which proves my ownership of the private account. It proves that I have a balance, and it's going to inside of my encrypted, it's homomorphic encryption using ergomal encryption in this particular case, and that it's going to actually update my account using rules that validate on-chain a zero-knowledge proof, which is this cryptographic proof that's generated off-chain. The on-chain contract is going to validate that proof and then update the amount that I have inside of my shielded balance on-chain. And that's something maybe we could talk about in a little more detail in some future talks. But since I've got this shielded private value that I can only see because I have the keys to be able to see that amount, what I can actually do with that is I can initiate a transfer to someone else who has private accounts. So I can take organization 2 and I can take some of those tokens, maybe half of them, and what I can do is I can transfer some of those tokens to them, and no one will be able to see how much I've transferred because it's going to happen through homomorphic encryption on encrypted balances and encrypted accounts. But at this stage, if the only 2 people who are involved are these 2 organizations' single accounts, there's no anonymity at this stage. So what I need to do is I need to create a mixer. I need to mix in an anonymity set of more accounts. And actually, I'm going to mix in just a random selection of accounts in this particular example. there's actually a heck of a lot to discuss around the set theory and how would you create the right anonymity set? How large does it need to be? Where do you get anonymity set? Are there enough people in the room trading at this point in time to really make it anonymous? But at this point, all I've done is just choose a random set, perform a transfer. And you can't tell who was involved in the transfer and who was just added in by me in order to shield who I really was transferring value to.
Yeah, and it looks like we almost don't have enough time to really dive into this, but what I do like about this solution that you've provided is that you really help the user to understand the limits of the ZKP scheme and how it's important to make sure that you have enough members participating to maintain a certain level of anonymity, right? So I think that that guided process that you've created really can help the user to avoid assuming that they're in an anonymous situation when they actually aren't, right? So that's really helpful.
Absolutely. And another thing the reason why we chose this particular technology as a great starting point to learn the technology is it interacts with those traditional token taxonomy based tokens like ERC20, which is tried by fire in the public Ethereum network. So you can use it inside your private environment and you can interact between these private darkroom trades. You can actually go and interact with those more obvious tokens that are managed inside of the Kaleido environment, automatically discovered. We detect that they exist. We track the transactions, and by then withdrawing some of those tokens from inside to outside, I can go across to Organization 2's visible external wallet that everybody can see, and I can actually see that those tokens appeared as a transaction out of the darkroom into that public space. So it's a really interesting way to see the interactions between public and private, but also the application of a zero-knowledge proof technology and the power of an ecosystem like the Ethereum one that really understands what these native constructs, whether you're doing it because it's some kind of financial use case, or whether you just need this core programming concept that is at the center of blockchain, like tokens, kind of pre-built, pre-hardened for you by the Ethereum community.
Excellent. So at this stage, Peter, are you thinking we should turn it over to some questions then?
Yeah, absolutely.
Yeah, so let's go down this list here for a minute. So one question we had was around whether tokenizing this particular demo, using tokenization in this demo would lead to manipulation of given tokens if they have value. And one of the things you pointed out was that it's really kind of up to the user whether they want to assign a monetary value, whether they want to allow participants to purchase tokens with actual funds, or whether these tokens are merely a scarce resource that exists in a virtual system that's designed to incentivize certain types of behaviors. And there's a whole field of behavioral crypto economics that's emerging now about exciting ways that we can get people to do things with tokens, right? This is something we could talk about for hours, and actually I'm fascinated by the topic. But there are different ways that we've done to, at least in the demo, we've shown that there's a rating that someone could attach to a source of data that would give some indication of the quality. You could also look at the number of downloads of that data to see whether this data is popular, right? So there's some things that you could do to prevent people from, tricking people into downloading, or uploading useless data. But an important point here is that if you never made these tokens cost anything, then there wouldn't be a strong incentive to acquire them outside of the actual activities that they enable within the system, right?
Yeah, I 100% agree with all of those points, and do want to just re-emphasize that this is a technology demonstration of how easy it is to get to the point that you can innovate at the application level, you can innovate at the ecosystem level, you can solve some of these hard and interesting problems around what does incentivization mean, what does healthy mean, how am I going to manage crypto economics, is a token right for me? that is what you can experiment with in your innovative individual for your industry application layer, and the plumbing is solved. And it's a real shame we've seen in the past, and hopefully won't see again as we enter the sort of next phase of adoption of blockchain, is a lot of projects that just got so stuck in the plumbing, and actually the innovation is all going to be in that layer around what does and doesn't make sense. Is a token right for this project? Is it not? Am I tracking something like entities privately or publicly? How much data should be public? How much data should be private? Fungible, non-fungible, some interaction between the two. There's just a huge amount of sort of interesting things to do, which are about business innovation, not plumbing.
Yeah, great response. So I'm okay with continuing with some questions if we still have time. We're right on the hour. I don't know what you're thinking, Peter. Do you want to take a few more?
I think what we'll do is we'll keep on. We're obviously very thankful to everyone who's joined. We hope everyone got some value out of the session. Everyone is welcome to stay on, and the session will continue while we answer a few more questions for a few more minutes. But thank you everyone for your time if you're dropping now.
Excellent. Okay, so we have this other question. Are the data feeds synonymous to oracles? And I think there's definitely some parallels there, wouldn't you say?
Oh, it's a fantastic question. Thank you to whoever asked that. So actually, we have built into the Kaleido platform Oracle technology as well. And for us, it's really interesting. We chose a technology called Chainlink to embed around an integration style Oracle, and we've also partnered to provide a custodian style Oracle to push data in. I'm going to focus on what I mean by sort of a customizable or integration based Oracle, and we chose Chainlink, which interestingly many people may have heard of from the sort of public blockchain space. You know, a really innovative and dynamic company in that space. But what
they're another one of our partners as well, actually. Chainlink is, yeah.
Oh, thanks, Carl. And the great thing about Chainlink is that they've got this great open source technology that allows on-chain logic with an API inside of your on-chain Solidity source code to orchestrate off-chain actions that perform side effects, tool REST APIs, invoke backend systems, capture data and results, and then trigger the next stage of processing, all in an end-to-end kind of flow. And Chainlink, another place where we partnered along with a number of others players in the space, is they're also part of the Hyperledger Avalon project, which is around trying to standardize the way that we're providing tool sets for on-chain logic to orchestrate off-chain compute.
Yeah. By the way, I just want to thank you for bearing with us a little longer. I know your cold is not a bit of a struggle here, but it's been really exciting and interesting. So let's keep going. Blockchain does not have data retention scheduling capabilities and will grow forever, which will eventually impact performance. What is your Kaleido's view on this?
Yeah, it's really it's a really interesting one. I think one thing which sounds obvious but hasn't always been thought of in the past in solutions, although certainly where we've the customers that we've really helped to be successful in production have thought about it. It's how much data are you putting in the transactions that actually are going to be immutably there forever. It's not just the type of the data, it's the size of the data you need to consider. But there are also lots of schemes around pruning the amount of data that you hold in memory, pruning the amount of data that needs to be cached on every node, the difference between archive nodes and nodes which are retaining a more minimal view of the transaction state. We're actually particularly innovative in Kaleido around this. We've even had technologies which have been able to take complete streams of transactions and take those transaction histories with original signatures and take them from one chain to another and even compress the chain. So it's an area which is evolving because actually the amount of time that blockchain's been around with the careful approach that's been taken on really good production networks, It's not grown over enough years have not passed for this to be an insurmountable problem with complete retention. But there's also a huge amount of work happening in public networks and also in organizations like Kaleido to help manage this data over time. And that's just going to continue to evolve.
Yeah, and what I would say to add on there is that, if you imagine a consortium chain where or permission chains as they're sometimes called, you've got far fewer participants, and if you've really thought carefully about which types of data you want to store on the chain and which data would be appropriate to store on the chain, with today's data capacities, in most industry use cases, I can imagine being able to store the data for indefinitely, because really, you're generating a lot less activity in a chain with fewer participants, right? If you imagine the current Ethereum public blockchain, which I think right now, in my most recent work on some node infrastructure, is running at about 160 gigs for a full node. You think of all the activity that's going on there, and all the thousands and thousands of participants. It's still within a size that is feasible for modern cloud infrastructure. But then you think of a small permission chain that's far less than that. It really isn't usually that big of a problem. But we always should be at least thinking of these things in the back of our minds as we're designing our applications, to make sure that we're not gratuitously storing a bunch of stuff on the chain that doesn't really need to be there, right? Typically, the chain is that, like we said in the beginning, that mission critical piece that's 5 to 10% of the whole application, right?
Yeah, totally agree with all that. I guess the only thing I'd add is that obviously another reason, there's kind of like 3 Ps that we talk about in private permission chains. And we talked a lot about privacy, we talked a lot about permissioning, but performance is also another reason. Predictable throughput, predictable ability to schedule those transactions and get them onto the chain is actually very a key tenet of one of the choice factors for using a permission network. And that does mean that there are cases where people are pushing much higher transaction volumes through chains, and that's something that certainly we're really happy to work with customers on. It's not a concern if you're looking at a higher throughput, but it does make sense to think about the size of those transactions when you're pushing, many transactions a second through a blockchain technology. You do need to think about, well, I'm doing that many times a second for years, and what's actually going to build up over time, and am I going to get ahead of the technology or ahead of the cost profile, all of these other things about the storage and other aspects in memory storage and also on disk storage that's going to be needed.
Yeah, this is actually really interesting. This is one of the exciting things I think about these permission chains and managed blockchain solution like Kaleido is that really, I think right now where a lot of the action is happening in the blockchain space generally is in enterprise blockchain, precisely because these permission chains are, achieve a level of scale right now that isn't yet feasible in a large public anonymous chain, right? So it's really exciting that industries and different verticals can already take advantage of blockchain technology, even if this consumer-oriented pipe dream of highly scalable, massive public chains is still a little bit into the future, right?
Yeah, and it's definitely getting closer and closer, and there's some great innovation going on for that world. But you're right, it's where to date in the enterprise space, it has been those permission chains, not least just for the simplicity of explaining to your participants, to your regulators, to yourselves, kind of like who's running my nodes. You think about the model of a public blockchain. It's a different, like, pragmatism is not a bad thing when you're thinking about completely changing from a model of complete ownership of your data to sharing a little bit, having a common source of truth with some other organizations. That's a huge step forwards. And minimizing how much kind of complexity is involved in making that massive and transformative step from 1 to 2 to 5 kind of participants in your network to 10 to 100 to 1,000. As you're going through that journey, you're making real innovative and really valuable steps as you go forwards, and overcomplicating it with lots of considerations that are going to be really hard to think about and manage over time. Just where we are right now, and that's kind of some of the reason why we've seen so much adoption and value captured in the private permission space.
Excellent. All right, well, let's grab another question here. So one guy is asking, this is Fawaz, is asking, on which side is the client front end, please? Is Kaleido taking the role of the back end of the stack here? Maybe you could go into a little detail there.
Yeah, so we're deliberately not providing the back end for your front end application server environment, the microservices platform on which you're building your, Node.js, Python, Ruby on Rails, Rust, Go application, your own business logic in the application tier, not the shared kind of back end. That you're going to build using modern development approaches on a platform like AWS, modern microservices approaches. You're going to build and host that in your own cloud account. So if we just pop back to the picture of the architecture here, when we look at it, that these services that are being provided inside the Kaleido managed infrastructure, think of them a lot like the services that you would often be taking off the shelf as managed infrastructure inside of your application stack, like your backend database. It's not customized to your use case. It's not your application. It's a piece of infrastructure that's general purpose and has the right characteristics for modern application development. It's the right APIs, has the right constructs to be really fast and efficient when you're developing your app. But actually what we had here was in your own private cloud account, you had your S3 bucket with your private data. You had the events being triggered into AWS Lambda functions when you're in your own private account. The application, the whole application stack of the back end and the front end with all of that modern microservice development in your own cloud account. Your off-chain cache database for your applications doing rich query against in your own cloud account. What's on the Kaleido side is that collaboration platform, the infrastructure that needs to be cross-connected, the infrastructure that makes application development simple and straightforward, even though you've got blockchain at the beating heart of this solution in a way that you're not used to having with these sort of centralized database applications.
Yeah, and I would add that there's a little bit of crossover in the fact that when you upload your contracts into these Kaleido blockchains, you're providing this REST API, right, which is allowing the user to, essentially interact with the logic that they've defined in their smart contracts, right? So there's definitely a lot of plumbing and convenience features in Kaleido that make it so that some of those core pieces of logic that are enforced by the smart contracts are easy to interact with, right? And also that you're not losing any transactions there or event notifications.
Absolutely. That's a great point. Thanks, Carl.
Yeah, great. So let's see. We have another one here. Someone's asking, could we not just do hash pinning to the public Ethereum network with a smart contract and index the hashes to the private data? What are the pros and cons compared to Kaleido private EE chain? So I guess he's talking about the data marketplace specifically here.
Yeah, so there are many use cases being built which are performing these approaches, not just using the public chains, but also using, and we actually provide a managed private permission version of this, peer-to-peer file system storage in order to share the data as well in a sort of peer-to-peer file sharing network, as well as using, and maybe you could perform cryptography to protect that data with keys which are shared off-chain rather than kind of having independent storage. Absolutely. And there's a huge amount of value that's being captured in that completely decentralized world, focused on end-to-end peer-to-peer transactions with sovereign end-user identity. I guess Kaleido's focus and the reason why we see such value being captured in the enterprise space at the moment with the current generation of the technology, with privacy, permissioning, and performance at the core, is that that value being captured in these private chains is allowing velocity of business value to be achieved by enterprise customers. And that's slightly different to the decentralized applications. The CryptoKitties isn't obviously the only example, but you know, these applications that are being built with blockchain at their core, considering privacy, that's a different space of innovation, and it's a fantastic space of innovation. And I would mention that Kaleido works a lot with the consensus ecosystem. So we see and work with all of that fantastic innovation that's happening using the public blockchains. And it's a space where there's going to be in the future a lot more crossover and overlap, almost like we're building these fantastic islands of value in the enterprise space, and there's going to be the bridges between those and the public. And the public is going to be a bridges between those value systems that we're creating in these enterprise permissioned environments today.
Yeah, in fact, that triggers a question I have around anchoring to public chain. Does Kaleido provide any features to help you if you want to, say, periodically anchor the state of your private chain with the public chain?
Yeah, thank you, Carl, for mentioning that one. Yes, so if we've got a private chain with a limited number of signers or validators, maybe that's a couple of dozen large enterprises. Now, that's a business ecosystem that's forming that's going to be hopefully more approachable, more open, better than one that just has, one organization that's in control of a centralized center of data. But with a couple of dozen organizations, a really efficient consensus algorithm, a straightforward processing, we've also now only got a couple of dozen organizations. What if those organizations want to prove to their ecosystem, which hopefully is going to be in the hundreds, the thousands of participants in their business ecosystem, using that blockchain, having maybe non-validator nodes on that blockchain, how do they prove that they couldn't collude between each other to change history? And proving that they couldn't collude is actually something that we see inside these private networks. So actually, when we first launched back in May of 2018, we already provided the ability for this private permissioned blockchain network to periodically pin a compressed history of that transaction state every few hours. That has signatures from all the nodes lined up using our own in-house algorithm that we worked through, and write that with a very, very small gas cost, very efficiently to the public chain. So that whatever that window is, let's say it's an hour or 6 hours or a day between those checkpoints, once the checkpoint's been written, there's no way to go back and rewrite history without also, beyond just that set of validators on the permission chain, actually also rewriting the history of that public blockchain network, which maybe has thousands of validators on it.
Excellent. Great. All right. So let's see. Let's try to bang out a few more of these. We have, is this REST API anchoring chain links technology? I don't think that's the case. Correct?
That's correct. So Kaleido has done a lot of work on the plumbing side of the REST API technology, the event streaming side of the event technology, this gateway technology that we've built, and also on that generation of the REST API. So that is actually one of the things where we just saw a gap, and we went and we really did go and look to fill that gap using our own skills. And a lot of what Kaleido's done has been building software componentry to build out this stack, using all of our experience, having been, through not just the founding team, but also others in the team that have lived what it means to solve these solutions over long periods of time. We're resolving problems here. these aren't so many new problems that we're solving. We're kind of resolving existing problems in an existing way. So this was dear to my heart because I worked in messaging and integration throughout my my middleware-focused enterprise career. And this problem, it just seems just so straightforward to me because ordering and sequencing of transactions, there's only two ways you can do it: order at source, order at target. You know, the technologies that you use, well, I've seen the evolution of the technologies. We knew, you know, the right technology to pick in terms of Kafka. And the alignment to the way that it does, both parallelism and ordering, that what we tried to do inside of Kaleido was kind of wrap all of this plumbing, deep, experienced engineering that we're able to do because we've seen it done so many times before with some of the blockchain kind of uniqueness to wrap it in the easy button, such as building all of that generation of the REST APIs, using, you know, modern Swagger, Open API formats to just like make it really consumable in that modern space. So it's kind of that easy button approach is, you know, part of something that we think is really valuable for the ecosystem of blockchain, and an area where we feel like beyond just managing and running production grade, cross cloud, reliable, high SLA infrastructure, actually contributing these stack components using our unique skill sets in the industry is something that we really want to add value and provide acceleration to our customers.
Yeah, I think it's extremely useful. Another question asks whether or not Kaleido is looking at potentially supporting Hyperledger Fabric in the future.
So it's interesting, the background of our team. I'm not sure if anyone on the call is aware, but we actually come from a really varied background. And Jim Zhang, my colleague, one of the other technical co-founders, is unique in the space as having actually seen and been a core maintainer on multiple of the top three of the enterprise-focused blockchain technologies, where those three are the Fabric ecosystem, including Hyperledger and the Hyperledger Fabric Codebase, Corda and the R3 ecosystem, and Ethereum, including Hyperledger, Besu, Quorum, and other implementations, Climatics, etc., of that core technology ecosystem of Ethereum. We started with Ethereum. We started in the consensus incubation for the Kaleido project because we just see it's such a vibrant ecosystem, and that's the place where we started. We are really an open, borderless approach. We really do keep our eye on what our customers need, and I would encourage anyone who's interested in the space to have a look at our blog, just kaleido.io/blogs, and have a look for Jim's recent comparison of those top three enterprise technologies. A real kind of unique perspective from someone who has worked on them. You'll see that there's been some input and feedback from the CTO of Corda in that as well. So a really kind of interesting insight into where the technology landscape is today, from the perspective of an organization like Kaleido that sort of sees that landscape. And I'm sorry, it's not a direct answer to the question, but yes, we understand the flexibility in choice, and yes, we're trying to make sure that we react to what the market and what value systems building business ecosystems need in order to accelerate and go fast.
Yeah, I definitely agree that there's a lot of exciting things happening, especially in the Ethereum space, and a large percentage of the dApp development is actually happening in that space. So I think it's smart to that you guys chose that as your initial focus, and I'm excited to see those innovations and additional features as they become available. So we've got a question about X509, but it looks like Nick, actually another member of the Kaleido team, has answered that in the text chat. So, but one final question that I see here is, are there any plans to integrate ENS, the Ethereum naming service, to Kaleido?
So that's an ongoing discussion, interestingly enough, when we have had significant projects deploy ENS. When we built the infrastructure, our infrastructure implementation of our on-chain registry, which is kind of the address book where you can store any information that's pinned to that X509 certificate. We did start from ENS as the core of that. It has diverged, and we're looking at whether we can, in the future, as part of the standardization exercise that we're going through with the EEA, consider what the right approach is to sort of bringing that back. But that's been a really hot discussion point as we evolve this technology, the pinning technology between the X509 and that on-chain address book. And we do, I mean, ENS is a really, really great technology, not just for sort of pinning data to an identity on the chain, but also for things like proxy-based routing and using naming and addressing to decouple your versioning and applications. And we've done a whole bunch of work recently that we didn't have time to go through today, but encourage you to go and read another blog that we've done on that around smart contract management and end-to-end tying kind of versioning of off-chain source code to on-chain transactions. And that's another journey where we're exploring on-chain versioning and concepts like ENS and on-chain proxies and the migration of the data, and we're exploring that as well. So long-winded answer, I'm sorry, but yes, a hot topic inside of Kaleido, and you can absolutely use ENS today, but the proxy contract is not a direct implementation of ENS.
Great. Well, you know, I think it's probably getting time to wrap up, Peter. I just want to say how much I've enjoyed the discussion that we've had, the real back and forth style here. It's been great to see a little bit more of your recent innovations up close, and especially in the context of this usable demo that can really give us a feel for what some of the possibilities that are opened up by decentralized applications. So thanks for having me on, and I hope we do this again.
Well, thank you, Carl. As always, it's a pleasure working with you and pleasure working with AWS. And really, thanks to, I see we've really got a good number of people who've chosen to stay on and give it a bit of extra time to hear what we've been talking about today and ask all those fantastic questions. So thank you to Carl, and thank you to everyone who's participated and joined in and listened to us talk through this today. And a last apology for how croaky I am on the call. I look forward, hopefully, to talking to some of you when my bosses got back together. Maybe some people will be able to engage and contact us offline. Talk to excellent people we've got on the team, like Nick Gatsky, that Carl mentioned earlier. Reach out to us, have a chat. Go and try the platform. It's free to sign in. Go to the AWS marketplace. You can sign in through AWS. Go to Kaleido.io and you can give it a try for free. See what we've been doing and reach out to us and talk to us about your use case. Yeah, and I should add, thanks especially for bearing with us, given your lack of a voice there. So. Yeah, you really went above and beyond in this particular case. Thank you, Peter. Thanks again, Carl.
Awesome. Thanks, guys.
Over to you to close out.
Yep, perfect. Thanks so much, guys. That was a really, really great discussion. Just as a reminder to everybody, we will be sending out the slides as well as the link to a recording of this presentation. So be on the lookout for that. We'll send that email out probably tomorrow. So thanks for hanging in there. I know we ran a little bit long, but really, really great conversation. I appreciate both Carl and Peter's time today, as well as everybody who attended. Have a great day.
Thank you. Bye-bye.